Hello, students. I hope you are doing fine at home. I have brought this lecture for you about measurement and scaling technique. See, in our life, we have different things, and those things have certain amount. And if they have amount, we try to measure it. We do measurements very casually in our life. For example, we measure height in feet, inches, and meters. We measure weight in pounds and kilograms. We measure temperature, time, volume, etc. So many things. So, how we measure? We measure them in numbers and we count numbers for doing measurements. So, in that sense, measurement is a description of any data in terms of number. But when we talk about physical objects, like I mentioned, it is very easy. So this is a quantitative data and can be expressed in numbers. But what if I ask you, how do you like the personality of your friend, or how much do you like a particular song or a particular painting? Then that will become a problem to define in exact numbers. So in that case, how can we measure it? For that, first of all, try to understand what is the meaning of measurement. Measurement means assigning number or other symbols to characteristics of objects according to certain pre-specified rules. For example, uh, we have a particular object, mm, cloth, suppose, and we want to measure its length. So, length is one parameter which has to be measured. So, we have assigned inches on a scale, and in those inches, we measure this cloth. So those inches are represented in numbers. So likewise, this measurement has three parts. Number one, selecting observable empirical events. Take another example. Suppose I want to know how many males and females are attending my lecture this time. So here I have selected gender as my observable event, which can be counted. So then the second part is to develop a set of mapping rule. What is this mapping rule? Mapping rule is a scheme of assigning number and symbol to represent aspect of event being measured. So what was the event being measured here? It was gender. And how can I assign number or symbol to it? Suppose I have made one rule that for male I will write a 0 and I will assign 1 for female. So whenever I will count male, I will assign 0 to it, and whenever I will count female, I will assign 1 to it. Now, the third step is to apply this mapping rule to each observation. I cannot change this rule in between any measurement. So this is the measurement. Now, these mapping rules have four characteristics depending upon the kind of processing we do. So these four characteristics are: number one, classification. Classification implies that we are interested in categorizing the data. We want to just sort our data into different classes. So this is called nominal data. The second characteristic of this mapping rule is that we are not only interested in classifying the data, but we are interested in their order also. We want to rank them or rate them. So this is called ordinal data. Then the third characteristic is the distance, whereby we are interested not only in the classification, not only in the ranking, but the distance between different ranks. And then is the fourth one, which is the origin. While the ranks will not specify the complete absence of that particular thing or the property, this fourth data will represent where is the absence lies, where is the origin, absolute origin of that particular property. So take these things one by one. We have two categories, two categorical data named nominal and the ordinal, whereby we only categorize the data into different categories or different ranks. Then we have two kinds of data, interval and ratio, whereby we are representing the distance and zeros in the data. So this way there are four categories and there are four features of these data. One is the distinct category, other one is the order category, third one is the meaningful distance, and the fourth one is the absolute zero. So these data will then be processed in future, and the operations possible with the help of these data are, like when we have only classes, we have only categories, then what kind of operation we can do? Minimum. We can just tell the difference between the two categories. And when we have order also, then we can tell which one is greater, which one is lesser. Not the exact difference. Then in the third category, we can do some operations, and in the fourth category, we can do every statistical and quantitative operation. So take it in detail. So first of all, we will take nominal data. Nominal data or nominal scale is a measure that can be used to classify objects or their characteristics into distinct classes. For example, we have these three nominal scales. Number one is asking for gender, whereby two categories have to be marked by the representatives. Number one is the male and the number two is the female. And in the second scale, the inquiry is about hair color. Here also different colors of the hairs are represented with the help of different numbers. 1 for brown, 2 for black, 3 for blonde, 4 for gray, and 5 for any other number. And then the third nominal scale is asking for the location of the respondent. So here also different locations are categorized with the help of different symbols of A, B, and C. So what does this indicate? This indicates that nominal scales or the nominal data is simply a system of assigning numbers or symbols to events in order to label them, so that their identification will become easier. For example, you may have seen the number written behind the back of football players or cricket players. So what does that number signifies? It does not have any quantitative value, means we cannot do much with those numbers, but it is a convenient label for the particular class or event. And this way, this nominal scale is called a weak measure, but still it is a very useful measure when no other scale can be used. It is mainly used in exploratory studies or ex post facto studies, and in the studies whereby the main purpose of any person or researcher is to uncover the relationships rather than securing precise measurements. So this scale only helps in keeping track of people, objects, or events, and simply describes the difference. Okay, there is a difference. What difference? It will not signify. So statistically, what we can do with this scale, we if we want to measure the central tendency, only one possibility of mod calculation is there, because we can know only the frequency of any events happening. So how much is the amount? How much is the count rather? So this is about the nominal scale. It simply means it simply tells you the insights into important demographic data patterns through classification. For example, when you are interested in knowing the respondent's gender, age, marital status, political orientation, their agreement, non-agreement, likewise. So one more thing I want to tell you in this is that whenever you have a nominal scale comprising of two categories, it is called dichotomous scale. Like in this screen, number one scale is a dichotomous scale. Only two categories are there, male and female. And another example is yes and no. Whenever a scale is asking for yes or no, then two possibilities are there. So it is called dichotomous scale. Now is the next scale, which is called ordinal scale. These scales include the characteristics of nominal scales plus an indication of order or rank. It takes into account relative positions of two or more objects. simply implies a statement of greater than, happier than, poorer than, without being able to tell how much poorer, how much greater, how much happier it is. Now, it only permits ranking highest to lowest. For example, in a class, we have students of different ranks, first rank, second rank, third rank, fourth rank, and so on. So, can you say that the difference of marks of different ranking students are equal? No, it is not there. Maybe possible the second rank holder is having only 1 or 2 mark difference, and the fourth rank um, student is having a difference of 10 marks from the third rank holder. So it is there. Another example is there on the screen in the first example. If you want to know about the feeling of somebody, so feeling is an abstract phenomena. It can be explained in a number of range. For example, here they have defined 5 categories of feelings, from ranging from very unhappy to very happy. So they have marked least for very unhappy category, and they have marked the highest for the very happy condition. So this way these scales um, arrange data. So this is a measure. Uh, the numbers here also are categorical. Uh, they did not have any uh, technical numerical significance. If we want to calculate measure of central tendency, okay, we can calculate frequency, and we can calculate mode here, and then it represents relative positions of the variables. That's why we can calculate median also. And for measure of dispersion, we can use quartile or percentile. And for calculating correlation, rank order method can be used. Now we can understand that only non-parametric methods we can use in these kind of data. So let's move on to the next category, which is the interval scale. It is having the properties of both nominal scale as well as the ordinal scale, but they have an additional strength of having the concept of equality of intervals. That is, distance between two ranks is equal. One can interpret not only the order but also the distance. For example, take temperature. Suppose we have measured temperature of Dehradun, Mumbai, Delhi and Calcutta as 10, 20, 32 and 22. When we take the difference between temperatures of Dehradun, Mumbai, that is between 10 and 20, it is 10. And when we take the difference between 32 and 22 degree temperature of Delhi and Calcutta, it is again 10. So we can interpret that the difference or the interval of temperature between these cities is equal. But can we say that the temperature of Dehradun, which is 10 degrees, and the temperature of Mumbai, which is 20 degree, is double than the other? No, we cannot say that. We can't say that 20-degree temperature is a twice warmer temperature than 10 degrees temperature. It does not have any significance. Why? Because it is an arbitrary region. We don't have an absolute zero here. We measure temperature against a zero, which is an imaginary zero, uh, and the zero represents nothing but the freezing point of water. Zero is a point where water starts freezing. So there is an absence of an absolute origin. That's why we cannot take their ratios. The intervals are adjusted in terms of some rule. Like here in temperature case, the rule was the freezing point of water, so as to make the units equal. It has an arbitrary zero and not possible to determine absolute zero. or unique origin. So this is the limitation of the scale. So true absence or a complete absence of any trait or characteristic cannot be located in this case. So ratios of such measures means nothing. So statistical operations, if we want to do with these kind of data, yes, in addition to nominal scale and ordinal scales properties, we have more operations possible through calculations. Like we can calculate mean also, we can calculate standard deviation also, we can calculate product moment for correlation, and we can calculate f value and t value for statistical significance here. So again, but its power is again limited. Next scale we have for solving those limitations is the ratio scale. It is a measure that has the properties of an interval scale, a nominal scale, and an ordinal scale together with a fixed duration or 0 point. As we see in length, height, there 0 means complete absence of length or height. So there we can take ratios, but these kind of scales are not very good for behavioral sciences, where we have no absolute figures for measuring attitude or motivation or opinions or feelings. So there these ratio scales do not work well, but yes, they facilitate comparison. Most they are most precise. Statistically almost all statistical techniques are usable in this case. So for preciseness and for more detailed informations, we should use a higher level scale like ratio scales. But uh, we have noticed here that there is an addition of information when we go from lower level scales like nominal scale to the higher scales. And when we move from higher level scales like ratio scales to the lower level scales, there is an there is a loss of information uh, in this measurement. So this is the compiled form of different scales I have mentioned to you. So let's take a recap. In scale number one, which was the lower level scale, weakest scale of all, nominal scale, the basic number identity and classification of object was possible. Example was our Aadhaar number. We every citizen has its own unique Aadhaar number, so it has nothing to do with the calculation. But yes, it is very good for identification. It only labels the identity of individuals. Then in marketing, we have product numbers. Different products have their own unique numbers. We can calculate percentage and mode with this. We can calculate chi-square, binomial test with this scale. Second is the ordinal scale. Ordinal scale, we have seen that it indicates the relative positions of objects, and the real magnitude of difference cannot be calculated with the help of the scale. Example includes quality ranking, ranking of groups in group events. Then in marketing, we have the example of market positioning of the product. Then statistical operation possible are the percentile and median, ANOVA, that means F test, rank order, correlation. Then the third scale is the interval scale, where we have seen that the difference between objects can be calculated. Example was temperature, and in um, human resource management, we have the calculation of opinion as the example. Then statistical operations possible are range, mean, standard deviation, product, moment, correlation. And the last scale was ratio, whereby we have seen that 0 is fixed and the ratio scale value can be compared. Weight, length is the example, and then sales figures represent the real ratio data. Statistical operations include geometric mean, harmonic mean, coefficient of variation. Thank you. It was all about scales. Goodbye.